Hi, everyone, and welcome to WOW 11 Day 3. Today's webinar, Reliability and Maintenance Issues for Industrial Process, presented by Odilon, Alladoum, is brought to you as part of Mobius Connect's Week of Webinar series. My name is Alexa Gruber, and I'll be your moderator for today's session. Just one quick note, this webinar is being recorded, and later you will be emailed a link with access to the on-demand version of this webinar. Now, if anyone has any questions throughout this webinar, you may type them in the Q&A panel on your screen, and at the end of the session, Odilon will be more than happy to answer your questions. Your questions will be answered on air anonymously, so no need to be worried about being called out. And if we somehow don't get to your question because of time, Odilon will be more than happy to reach out to you after this webinar to make sure that those questions are answered. All right, without further ado, I'm going to go ahead and pass the presentation over.
Okay, hello everybody. Welcome to all participants to this webinar. It is a great pleasure for me to be a speaker at this webinar. I would like to shout out to Mobius Connect team and Aline, Alex on page for all that was done from the beginning to this moment. My name is Odilon Alladoum. I am a certified reliability engineer, and I am also a yellow belt certified Lean and Six Sigma. I'm co-founder and business development at Industrial Solution Company. We provide trainings, consulting, and furniture to help our customers to improve their productivity. Before my current position, I am at Industrial Solution Company. I have spent time in factory as factory manager, and I was also lubricant engineer. You can find more about my background on LinkedIn. In this webinar, we will share with you some concepts that will guide you to assess your reliability and maintenance optimization issues in order to define successful strategy for your process. So the presentation is outlined as follows. First, industrial process in our everyday life. Secondly, some definitions, and we will see some major issues in industrial processes. And we will also see how to define your process reliability and maintenance optimization issues, and we will conclude. So what is about industrial process? Our modern world relies on industrial processes in every aspect of our lives. In our home and works, most of product and equipment come from industrial processes. Water, gas, electricity, even food come from industrial processes. Our everyday life depends on industry, and we cannot imagine the world without these industry like power plants, refinery, food industry, etc. To continuously supply our needs, industrial processes must be kept in good and efficient operating condition. This vital role is filled within organization by reliability and maintenance departments that are the heart of business success. Reliability and maintenance professionals deal with many challenges to achieve smooth and sustainable support to operations. So it is important to know what are the most relevant issues faced by reliability and maintenance professionals to give more satisfaction to stakeholders that expect a lot from them. We will discuss it in this.
I'm so sorry. I'm so sorry, but can you put your screen to full screen? We see a smaller version.
My screen?
Yes.
Oh, no, okay.
It looks like it's not in presentation mode.
Okay. I'm still in the first slide. I am here.
Is maybe.
Now I am moving to the next slide. You can see.
I can see the slide, but it looks small. So at the bottom of your screen, hit the full computer. So hit like full screen.
Full screen. I put it in full screen now. This is the full screen.
Okay.
It is okay for you or not? Not yet.
It still looks a bit small.
Okay. If possible, you can run it from your site, so I can just um, do the presentation. So let me stop, and you run it from your site.
I don't have your screen. Give me 1 second.
Okay, choose the screen.
All right, I just got your name. Give me 1 second for the screen to load.
Okay. Yeah. Now, could you see it, my screen, or not yet? Now it is on full screen.
Hey, Odilon, do you have more than one screen?
No, I have just one screen.
Um,
Okay, let me check my parameter here. Let me check.
is there a full screen option on that tab?
I just put one screen.
Can you click that orange button in the upper right-hand corner? The orange button, the orange tab.
Yeah. One moment.
Mm-hmm. Okay, that does look better.
Okay.
Okay, that should be fine.
Okay.
Okay, go ahead with your presentation. I'm so sorry about that.
Okay, no problem. Okay. We discussed about industrial processes in our everyday life. Now, let us see what is an industrial process. The ultimate goal of any industrial process is to transform input to output. So, as for example, we have power plant, refinery, cement production plant, food industry, transportation industry. And all of these industrial processes are consisting of steps that transform inputs to outputs. Inputs are raw material, energy, tools, human works, etc. Output could also be in the same categories than input. They can be a physical object or services. The different step in industrial process requires the use of assets that need some care to conserve individual or overall performance. So we need to set a strategy for reliability and maintenance to keep running our processes. So there are basically two main categories of industrial processes. We have continuous processes and discrete processes. Continuous processes are those that work continuously without a breakdown and sequences. Input are supplied continuously and output are delivered also continuously. For example, we have energy process like power plant and refineries. And the discrete processes are those that process an item or a group of items through each step. If items are processed in a batch, then we have a batch process. Processing allow you to set up each process uniquely to adapt the material you are working with. In discrete processes, in each step, one item is processed example of car industry, public work, etc. Each of these processes subcategories has its individual challenges. That's just that we must identify to make the best choice for each equipment. Now let us see what does a process or asset require. We know that to achieve the company goal, we use asset in our process. This asset must be available to perform the required functions. So our responsibility is to take care of this asset in such a way that the performance is not altered. There are three main attributes that contribute to asset performance. We have inherent reliability, we have a maintenance plan, and operating environment. So let us see in what is reliability and inherent reliability for industrial processes. The reliability is the component of our strategy that reinforces our confidence to run our process or equipment without a breakdown during a specified period of time. In other words, it is the probability that an asset or item will perform its intended functions for a specific period of time under stated conditions. It depend it depends both on internal and external factor of an asset. So a reliable process should be operationally ready all time, and it is easy to predict the quantity and the quality of its output. In addition, a reliable process should be cost efficient and conform to environmental regulation and standards. Each asset has it is built-in reliability, as we said. This built-in reliability is called the inherent reliability that we have here. This inherent reliability doesn't depend on operational condition. It depends rather on manufacturing and the design. We can see here. It depends rather on manufacturing and design. So when we bring a new equipment to a field, it is impacted by operating condition. The value of reliability obtained from the field is called operational reliability. This is the operational reliability, and we have the inherent reliability here. The value of reliability obtained from the field is less than the value of inherent reliability. This is a relationship between operation reliability and inherent reliability. K is the safety factor of the asset. It depends on all constraints and operating conditions. So in a cost-efficient process, the value of K should be closer to 1. This means that we must put in place some maintenance and reliability strategy to keep our asset in good working conditions. Now, how we can compute or calculate the reliability of a system? In a process, the configuration may be in series or in parallel, or a combination of series and parallel. In series configuration, system or component are arranged in series. If any one of the system fail, all the system fail. The Achilles heel of series configuration is its weakest component. This is the graphic of a series system of n component in series, and each component of the system is represented by a block. The system reliability is equal to the product of the reliability of individual component. This is the formula that can help us to calculate the reliability of all of the system. In parallel system like here, the entire system continue to work if some of its component fails. In contrast to series configuration, the total reliability is higher than the reliability of any single component. This is a graphic that shows a description of a parallel system of n components. But there are some systems that are made up of combination of several series and parallel configuration. The way to obtain system reliability in such cases is to break the total system configuration down into homogeneous subsystems. Then consider each of these subsystems separately as a unit and calculate the reliability. In summary, if we want to analyze the reliability for an industrial process, first we must know the system, how the system is configured, and we have also to describe the system and draw the block diagram. Now let us define what is maintenance for industrial process. Maintenance is defined by IEC has the combination of all technical and management action intend to retain an item in or restore it to at a state in which it can perform as required. Technical activities are those that are carried out to restore an equipment or prevent it from failure. Management activities support maintenance work like maintenance program development, planning and scheduling, work management, spare part management, etc. Both technical and management activity are complementary and necessary to reduce breakdowns, to increase the uptime, and to promote the overall reliability. But what are the different types of industrial maintenance? Um, Industrial processes fall into the following maintenance approaches. There are maintenance that are done after failure and those that are done before the failure. After failure, we have corrective maintenance. Corrective maintenance is about maintenance tasks that are carried out when an equipment breaks down and or is showing signs of poor performance. And we have a preventive maintenance that is about maintenance tasks that are carried before the equipment fails. So preventive maintenance tasks are carried on usage or calendar-based schedule to avoid catastrophic failures on critical equipment and save money. In addition to preventive maintenance, we have a condition based maintenance that is called also CBM or predictive maintenance. The goal of this approach is to identify proactive activity to carry out at a scheduled time when the maintenance activity is the most cost effective and before the asset failure. CBM use technology like vibration analysis, like oil analysis, infrared thermography, etc. So CBM provide good saving compared to preventive maintenance. The next step is about maintenance optimization. Maintenance optimization is about when we want to optimize our maintenance program. This means that we want to do what is necessary to keep our plant in good operational condition. We start by analyzing the existing to find what need improvement. The results of our analysis will lead us to decide on what to remove, what does need adjustment, and what to keep in state. In summary, we focus on tasks that minimize the downtime while providing the most effective use of our system in order to secure the desired results at the lowest cost possible. We take, for that purpose, all constraints into account. This work is done on the basis of criteria that reflect our organizational constraint and objective. The most used criterion are replacement interval, availability, and profits. So Now let us discuss operating environment. What does mean operating environment for industrial process? Operating environment refers to operating condition of an asset or process, like physical parameter like temperature, ambient operating temperature, relative humidity, pollution, or operating altitude, or operator skills. So, operating environment is a real environment where the asset operates. The operating environment is different from the conceptual one that is used only for design. How the environment is different, it may cause more failure or failure mode may occur than where addressed during design or manufacturing. So understanding the operating condition is a key to adjust our maintenance and reliability strategy. We observe this kind of practices in lubrication, for example, when the operating conditions are severe, for example, in dust, humidity, or high temperature, the lubrication are reduced. Um, this graphic show the study conducted by experts in the field of maintenance and reliability. It is show that almost 40% of failure are caused by operator skills. The main problem identified are lack of training to operate assets, lack of responsibility of monitoring performance, or abnormal condition and taking corrective action. So we have finished with the definition we have defined some terms that are used in this presentation. Let us now discuss the major issues in industrial processes. So the objective of an industrial process is to create value with a predefined quality. In order to achieve this goal, some internal and external interaction are needed. These interactions have influences on the process. We must know what are these influences and how they could impact our environment activities. The level of importance of an impact may turn it to an issue or not when we develop our reliability and maintenance strategy. Some common reliability and maintenance optimization issues are quality improvement and stakeholder satisfaction, improvement of asset or process availability, reduction of process, operating costs, people and asset safety assurance, improvement of carbon balance and reduction, elimination of failure risk. Now let us see what is about quality improvement. Philip Crosby said that the quality is free. It is not a gift. The unquality things are what cost money. This means that it is important to do things right the first time. If you don't do so, it will we will pay for unquality. Doing things right the first time means also that we need to keep the quality over the time to meet stakeholders' satisfaction. These stakeholders are employer, employee, shareholder, customer, user, etc. So this means also that the starting point of reliability is the starting point of process quality. If you need to assure quality improvement and the satisfaction of our stakeholder, we need to start by reliability. So quality improvement and stakeholders satisfaction are important issues to take in account when we develop reliability and maintenance optimization strategy for our process. Reliability and maintenance teams must participate, understand the objective of quality, and contribute to reach these objectives. The next point is about reduction of process operating cost. So basically, there are two ways possible to reduce the process operational cost. First, we can reduce the cost of product. This could be possible through selecting good method of manufacturing, selecting cheap raw material, reducing workforce costs, etc. On the other hand, we can achieve this goal by improving asset um, reliability. It is demonstrated that the operational costs in the process also depend on its reliability. As we are concerned about maintenance, optimization, and reliability, we must understand that the reduction of process operating costs is a great challenge, and we must take it into account in order to develop an efficient reliability and maintenance strategy. The next point is about improvement of asset availability. Some failure may have serious consequences to human being, economy, society, or environment. Consequences might be minor, moderate, major, or extreme. Reliability and maintenance optimization strategy must be aligned to address properly our process failures. The better thing we can do is to reduce failure through some action to avoid serious consequences. It is our responsibility as maintenance and reliability to do so. It is not only HSC manager or operation manager to define what to do. We must participate and take in account those constraints to contribute to better process utilization, lower scraps, and a higher process efficiency. By this way, we can minimize resource, reduce rework, use less labor, and use less material and energy. The next point is about, excuse me, I shift directly on process availability. Before we were here, now we are here. So operation um, or manufacturing cost depend on process productivity. The productivity is not a standalone concept. It depends on availability. Good productivity means that we operate with less downtime at the right speed with minimum quality losses and transition time. Maintenance and reliability professionals are concerned with losses too. Both operation and maintenance be must coordinate the efforts to keep asset to be in a state to perform as required. In other words, asset must be kept available. As we know, availability is a function of reliability and maintainability. The first point is about reliability. This means will our equipment perform its functions over the required time? What can we do for that purpose? And about maintainability, it means how fast we can restore or repair an asset that fails. Maintainability is defined as a characteristic of a design or installation of an asset. It is the ability of an asset or an item to be retained in or restored to a specified condition within a given period of time when maintenance actions are performed in accordance with prescribed procedures and results. Reliability and maintainability have a direct effect on asset availability and process efficiency. To have a satisfactory level of availability, we need to define required level of reliability and maintainability through planning and design, data analysis, process assessment, or feedback for continuous improvement. Another point is about another major issue is about safety assurance. We know that some industrial failures may be very dangerous for human being when they happen. They can cause employer injury, fire, explosion, sickness, or death, microbiological risk, allergen risk, or waste, etc. It is particularly important in transport, where accidents due to failure may lead to human life losses. There are some consequences that are impossible to be contained in a time span or in one location. For this kind of processes, it is important that some rigorous actions are put in place to reduce failure risk to zero. You see, Colin McLean said that a safe site is a reliable site, and it is a cost-efficient site. In practical terms, this means that we must promote the basic of excellence of maintenance excellence management to support safety management, because HSE manager cannot achieve the safety goals alone. He can provide us with tools and trainings to support the culture change, but success depends on everybody in the company. And many studies show that reliability and safety are correlated. Where there is a strong reliability culture, it is safe. So safety must be considered as an important issue when we develop our reliability and maintenance optimization program or strategy. The next and the last point for this presentation is about the environmental protection and reduction of energy consumption. So, in environmental protection is the big challenge nowadays. Throughout all maintenance activities, we must consider our impact on environment. And we know that many countries and majors signed the Paris Environmental Agreement. This means that we this means that they accept to contribute to cut emission and slow the global warming. From business perspective, this contribution depend on how we affect natural resources and the environmental quality. It is clear that there are many maintenance activities which could affect the environment if they are not designed properly. So the next point about this issue is the energy consumption, because all form of energy generation have an environmental impact on air, water, and land. Energy losses due to equipment or process inefficiency may have a negative impact on operational and financial performance of a company. So good energy management by producing and using electricity more efficiently can help to reduce the quantity of fuel needed and the amount of greenhouse gases and other air pollution emitted as the result of our electricity generation. So for um, for good energy management, we need to take some action. For that purpose, As maintenance and reliability professional, it is important for us to understand the way that energy is used and wasted. Maybe we know common equipment that consume a lot of energy, as for example boiler steams, heating process, motors, pump, fans or compressors, etc. For those kind of equipment, the development of maintenance and reliability program must take in account improvement opportunity to reduce energy consumption. Proper action must be set to address common reliability um, impact of energy consumption, such as idling, running, oversized equipment, or and gas on the leaks. Beside the energy and the environmental protection, we have also water consumption. Water consumption without a good control is a problem for our environment. One thinks that water is free and use it excessively in heating, cooling, and cleaning processes. But we must know that abnormal use of water is not cost efficient and good for environment. So, in summary, for this point, it is important to seek for means to reduce material consumption, to reduce energy consumption, and to eliminate hazardous material when we develop our maintenance and reliability strategies. Here are some example of action plan that we can put in place. We can, for instance, reduce use high performance lubricant to reduce our lubricant consumption. We can put in place a condition monitoring on pipe to detect leaks at the beginning stage. We can control light with motion sensor to reduce their energy consumption. We can control also overheating of motor or heating processes to reduce energy losses. There are some standards that can help us to broaden the understanding of these subjects and define adequate reliability and maintenance strategy to address environmental protection and energy management challenges. For example, we have ISO 14,000 series for environmental management system, and we have also ISO 50,001 for energy management. All these issues that we just saw are general, but sometimes you will need to find your own issues for your process. So uh, we must know that there are many reliability and maintenance optimization issues that impact industrial processes performance. The level of importance of issues in our strategy depend on many factors such as location, country, regulation, and company strategy. So it is impossible to set a formula for all industrial processes. Um, for each process, we recommend to collect data, to analyze the data to identify the current state and define a successful action plan to implement and improve your process efficiency. So, analysis can be done by through company SWOT analysis or process SWOT analysis. SWOT is a widely used methodology for strategic analysis. The acronym SWOT means strengths, weaknesses, opportunities, and threats. So strengths refers to our inherent abilities to do better than our competitors, and also reliability and maintenance professional in similar conditions. Weaknesses, W, are our inherent deficiency that need improvement. Um, it means also what are our reliability and maintenance practices where we are bad. Its strengths and weaknesses are related to our internal processes like people, skills, operation, marketing, safety, etc. In contrast, we have O for opportunities, um, and T for threat are from external environment. Opportunities are good influence to our activity from external environment, and threat are constraint or risks that might suppress our strengths or accelerate our weaknesses and stop us from growing. For example, regulations are constants that we must comply. When we know our strengths and weaknesses, opportunity and threat, we can combine them to set a strategic direction on which we must align reliability and maintenance optimization issues in response to major issues. So there are four combination possible. We can combine strengths and opportunity, weaknesses and opportunities. We can also combine strength and threats, and we can also combine weaknesses and threats. So for each combination, we will set some direction. So when we have set directions, which are the basis of reliability and maintenance optimization, perhaps we will need further analysis to prioritize the strategic direction that we have set. So these the strategic direction are that we have set are our main objectives to address main issues that we have identified. So we need now to break down direction into a small step to to implement them. So to each action or step, we will allocate some resource like labor, time, material, financial resource for the execution. We must also define when we are here, we implement our strategy. We must define also KPI to track our performance and verify over the time if we are we are reaching our objectives or not. But it is important that KPI must be linked to the main issues they address to tell us if we are giving satisfaction to our stakeholder or not. So we have finished with the presentation, but it is important to know um, that the success of reliability and maintenance optimization program depend on how good we are in accessing our process issues. We can assess our processes issues by taking into account our stakeholder expectation. This could be done through analysis of major industrial process issues or through SWOT analysis that will help us assess our strengths, weaknesses, opportunities, and threats. So I have finished. Uh, Thank you for your attention.
Wonderful. Thank you so much, Odilon. We do have a couple of questions that came in during your presentation. The first question that we have is, what is TQM? It was on one of your slides.
Um, TQM is about total quality management. It is a concept that of a quality that concerns all the company. The quality goals or programs are implemented through all the company to improve the quality of a product.
Okay, perfect. And then another question, out of all of the major issues that you discussed in your presentation, what would you say causes the biggest problem in industrial process?
From main issues that we discuss in this presentation, um, due to the, nowadays context, these issues are the main that to take into account, and the most important is quality. Is quality because in every plant, we every plant or every company we want to create value. So creating value depend on the quality of our product. And it is okay.
Oh, okay, perfect. And then if someone wants to get in touch with you, how can they contact you?
Okay, if someone would like to reach me, they can send me an email to my email address, but I didn't display it on the presentation. But I advise that they contact you and you can refer them to me to answer their needs.
Alrighty, perfect. So if anyone has any more questions that they'd like to ask, go ahead and leave them in the Q&A panel, and Odilon will go ahead and answer those when we send him the questions later.
Okay.
Presentation. Thank you so much for your presentation. We want to thank our WOW 11 attendees as well. And we are pleased to provide you with 50% off your conference pass to the CBM and Reliability Live Training Conferences happening in Mexico in August and Australia in November. You can use the code WOW50 and reserve your seat to take advantage of this discount. These events will include certification training opportunities, hands-on workshops, and case study sessions. You can visit the MobiusConnectConference.com and learn about these live and in-person events. You can also find a link to register in the follow-up email after this webinar. And before we close things out today, Odilon, is there anything else that you wanted to add?
It is okay for me. I would like to thank say thank to everybody, and many thanks to Mobius Connect and all the team of Mobius Connect for giving this opportunity to share with others. And thanks to all participants.
Oh, thank you so much. For anyone who is joining us next, we have The Way to Truly Easy Condition Monitoring by Daniel Dudak, and that is at 9 a.m. Eastern Time. So if you haven't signed up already and you would like to attend, you definitely may by going to your attendee hub and clicking Join Now or looking for the link in our Mobius Connect LinkedIn page. And just as a quick reminder, look out for an email from us containing the on-demand version of this webinar and your certificate of attendance. And if you are interested in engaging with other industry professionals or would like to participate on the industry's live feed and forums on Mobius Connect, you can visit MobiusConnect.com to create your free profile, and be sure to follow us on social media at Mobius Connect to stay up to date with the latest community happenings. Now, if you have any questions, please email the Mobius Connect team at info@mobiusconnect.com. All right, thank you, everyone. Thank you. Have a great day. Please stay safe, and we'll see you next time.